Welcome to qnawire.
To approximate the area of a lake, a surveyor walks around the perimeter of the lake, taking the measurements as shown. We know that V is 45, that W is 40, X is 35, Y is 85, Z is 15, angle F is 10 degrees, and angle G is 95 degrees. To find the area of triangles, we can say that the area is equal to 1/2 times 2 sides and the sine of the included angle. This is just in general, right? That's generic. So we actually have enough information to find the area of the top triangle would be 1/2 times 35 times 85 times the sine of the included angle, 10 degrees. Okay. But we got to find information to help kind of figure the rest out. So if we take the small one at the bottom here, 95, there's always 180 degrees in a line, so this has got to be 85 degrees inside the angle, and we'll care about that one because now we have enough information to find the area of that triangle. 1/2 times 15 times 45 times the sine of the included angle, 85 degrees. Now we need to figure out some information for that middle triangle. That's where quite a bit of extra work might need to be done here. We can use the law of cosines to find these two lengths. Let's go with the top one. Using the law of cosines, we can find that distance because we know the opposite angle and the other two sides. So by the law of cosines, that would be, I'm going to just call it x, would be equal to the sum of the squares of the other two sides, 35 and 85, minus 2 times 35 times 85 times the cosine of the included angle, which is 10 degrees. And so x is the square root of all of that. I'm going to call the other one y. Different than these y, that should use different variables, but that's okay. Keep following me. We're going to do law of cosines with 15, 45, and 85 degrees. Maybe I'll just call these A and B because it really just doesn't matter. I just don't want you to get confused with the other variables. That would be the square root of the other two sides, 15 and 45, times the cosine of that included angle, which is 85 degrees. And so that'll give us all of the sides, which would then we can find an included angle. Let's make some calculations. We need to be in degree mode. We've got the square root of 35 squared plus 85 squared minus 2 times 35 times 85 times the cosine of 10 degrees into 4 decimal places would be 50.8959. All right. The second one using the law of cosines uses 15, 45. So it'd be the square root of 15 squared plus 45 squared minus 2 times 15 times 45 times the cosine of the included angle 85 degrees. So that's 46.1773. All right, so now we know all three sides of the triangle. And let's use the law of sines to figure out, no, actually we're gonna have to do the law of cosines again to find the included angle. To save some work, you could find any of the angles, so I guess it just really doesn't matter. I'm going to find the angle between the two. Yeah, it'll be fine. Just keep rounding to 4 decimal places. So I'm going to use the law of cosines to find the angle opposite side 40. So 40 squared would be equal to the other two sides squared. And I'm just going to call this cosine of A. So we're going to subtract 40 squared. Well, from 40 squared, we're going to subtract 50.8959 squared and 46.1773 squared. And then divide by -2 times 50.8959 times 46.1773. So we'll have subtracted, and then divide so that we're equal to the cosine of A. And so then angle A would be equal to the inverse cosine of all of that. So I can go to the very beginning, I believe, and take the inverse cosine of this. Which is 48.3679. 48.3679 degrees. And we can now calculate its area by 1/2 times the two sides. This isn't this included angle here that I found, so we're going to have to use the two sides, 50.8959 times 46.1773 times the sine of 48.3679 degrees. And then we have all of our areas. So I'm going to start with that in the calculator. 1/2 times 50.8959 times 46.1773 times the sine of 48.3679 to that, or I'm just going to say 87.3135 878.3135. And I'm just going to keep it going in the calculator, but I'm going to go backwards now. So I'm going to add to that 1/2 times 15 times 45 times the sine of 85 degrees. So that's accounted for, and then I have to account for the other triangle, 1/2 times 35 times 85. Times the sine of 10 degrees. We got 1472.83 final answer. 1472.83, and this would be in square feet.